You clicked because the sky over the East Coast feels off this week. And you were right too. The next 10 days are not going to behave the way the calendar says they should. Here is what I found. A buoy sitting 60 nautical miles east of Cape Hatteras is reporting ocean water running far warmer than it has any right to be this late in the season, and a pressure block is setting up to the north that can pin a storm against the coast for days instead of hours. That reading comes straight off the National Data Buoy Center feed and the Climate Prediction Center's own ensemble maps. I was watching that buoy feed close to midnight when the number flashed, and I read it 3 times before I let myself believe it. Stay with me, because the piece nobody has put on screen yet is a dated tide window somewhere between the 14th and the 17th. That changes everything about how bad this could get. And it does not matter how far from the beach you live. Let me show you exactly what stopped me. The station is called Buoy 4, 1001. It has been anchored out there in the deep water off the North Carolina coast for decades, and it reports back sea surface temperature every single hour. For this stretch of the calendar, the water out there should be somewhere in the low 70s and starting its slow slide toward winter. When I pulled the latest observation, it was reading close to 78 degrees Fahrenheit. That is not a rounding error. That is roughly 5 to 6 degrees above where that water normally sits right now. And in the ocean, 5 degrees is an enormous amount of stored energy sitting in one place. Here is why that one number matters so much. Warm ocean water is fuel. It is the gasoline that storms burn. A coastal storm passing over water, that warm does not just survive, it strengthens. The evaporation feeds the system, the pressure drops, and the winds tighten. When I saw 78 degrees on that feed, my first thought was that the sensor had drifted, because that is the boring explanation, and usually the correct one. So I did what I always do now. I cross-checked it against the nearby buoys and against the satellite sea surface temperature analysis. They agreed. The Gulf Stream is running unusually close to the shelf, and it is dragging a tongue of bathtub warm water right up the doorstep of the mid-Atlantic. Now here is the part the quick summaries left out, and this is where I started paying real attention. Most of the coverage I saw this week mentioned that a system might develop and left it there. A single sentence buried under the weekend forecast. Nobody connected that warm water to the second reading I was staring at, because warm water on its own is just potential. It needs a trigger, and it needs something to hold it in place. And the maps were showing me both. So let me walk you to the second reading, because this is the one that turns a passing rainstorm into a 10-day problem. Up over the North Atlantic and toward Greenland, the ensemble models were building a ridge of high pressure. In the language the forecasters use, this is a negative phase of the North Atlantic Oscillation, and a negative North Atlantic Oscillation is a traffic jam in the sky. High pressure to the north acts like a wall. Storms that would normally sail out to sea and away from the coast in 12 to 24 hours hit that wall and stop. They get blocked. They sit and spin off the shoreline, hour after hour, tide cycle after tide cycle. The Climate Prediction Center tracks this index directly, and their forecast had the North Atlantic Oscillation dropping into solidly negative territory for the middle stretch of the 10-day window. When I line those two things up side by side on my own screen, the warm water reading from Buoy 41001 and the blocking ridge from the ensembles, my stomach dropped a little. Because I have seen this exact fingerprint before, warm shelf water plus a northern block is the recipe that has produced some of the worst coastal flooding events this coastline has ever recorded. It is not the wind speed that gets people in this setup. It is the duration. Think about what duration actually means when you live near the water. A normal coastal storm comes through, pushes water up for one high tide, maybe 2, and then it moves along and the water drains back out. That is survivable for most people. But a block storm parked offshore keeps the wind blowing onshore from the same direction for 3, 4, even 5 straight high tide cycles. The water never gets a chance to fully retreat before the next high tide piles more on top of it. That is how you get water in living rooms that never flooded before. That is how a marsh that is held for 40 years suddenly comes over the road. Therefore, the real question I needed to answer was not whether a storm would form. The maps had already told me the ingredients were on the table. The question was how long the block would hold and how high the water could stack while it did. And to answer that, I had to look backward, because this coastline has a long and brutal memory, and the record keeps receipts. Let me take you back to the precedents, because they tell you exactly what this pattern is capable of when it locks in. Most people on the East Coast remember Superstorm Sandy in late October of 2012. What made Sandy so catastrophic was not that it was the strongest storm ever measured. It was the angle and the block. A ridge to the north forced Sandy to take a hard left turn and slam straight into the New Jersey coast instead of curving out to sea, and it drove a wall of water into New York Harbor. The water level at the Battery in Lower Manhattan reached just shy of 14 feet above the low water mark, shattering the previous record. That storm caused somewhere north of $70 billion in damage and was tied to more than 150 deaths. The block is what did it. The atmosphere refused to let the storm leave. Go back further, and you find the Ash Wednesday storm of March 1962. That one gets forgotten because it was not a hurricane and it never got a catchy name, but the people who lived through it never forgot. It was a nor'easter that stalled offshore and pounded the mid-Atlantic coast through 5 consecutive high tides. 5. It ravaged the shoreline from North Carolina to New York, destroyed thousands of homes, and it is still ranked among the most destructive storms in the region's history. And it did all of that with wind speeds that would barely qualify as a strong tropical storm today. The damage came from the stall. The water simply had nowhere to go and no time to go there. Then there is the one they made a movie about, the so-called perfect storm of late October 1991, when a nor'easter absorbed the remnants of a hurricane and generated waves recorded above 30 feet off the New England coast. Every one of these events shares the same DNA. Warm water offshore, a blocking ridge to the north, a storm that will not leave. And every single time, the coverage in the days before focused on the wrong thing. So this is the moment in my investigation where the outrage started to build in me. And I want to be honest with you about why. When I went back through the way these setups get reported, I noticed a pattern that is almost as consistent as the weather pattern itself. The reported version leads with the peak wind gust, because a big wind number makes a dramatic headline. But in a blocked coastal storm, the wind is not the killer. The stalled water is the killer. And the water level threat is the part that gets one line at the bottom of the segment if it gets mentioned at all. I am not telling you anyone is hiding anything on purpose. I am telling you that the format rewards the flashy number. And the flashy number is the wrong one for this exact kind of storm. The people who lose their homes in these events almost always say the same thing afterward. They say nobody told them it would be the water, and nobody told them it would last that long. That is the whole reason I stopped trusting the summarized version and started reading the raw feeds myself. And everything I have learned doing this, the method, the specific feeds, the way I layer buoy data against tide tables, against blocking indices, I put all of it into a series of books called Storm Ready, Storm Signal, and Storm Protocol. Each one builds on the last. And together they walk you through exactly how to read the same raw data I just showed you, step by step, so you are never again dependent on a headline to know whether your family is in danger. You can find them linked in the description below. If this video made something click for you, those books are where you go deeper. But here is where I have to stop and talk directly to the person watching this who is thinking, this is not about me. Maybe you live 40 miles inland. Maybe you are up on a hill, nowhere near a beach, and you have already decided this is a coastal problem for coastal people. I need you to stay with me for the next 2 minutes, because this next part is specifically for you. and it is the part that catches inland families completely off guard. When a storm stalls off the coast for days, it does not just push ocean water inland. It dumps rain, and it dumps it over the same river basins for days without moving. A blocked system is a rain machine that sits in one spot. The ground saturates, and then every additional inch runs straight off into the creeks and the rivers. And here is the trap. The rivers that drain toward the coast cannot empty properly when the ocean end of them is being held high by the storm surge. The water backs up. So you get freshwater flooding rushing down from upstream meeting, saltwater flooding being shoved up from downstream, and they collide in the middle, which is exactly where a lot of inland towns sit. This is called compound flooding, and it is one of the most studied and least talked about hazards in coastal science right now. So here is the one concrete thing I want you to do today, no matter where you live on the East Coast, inland or not. Go and find out what river or creek basin your home drains into and look up whether you are in a mapped flood zone. You can do this in about 10 minutes on the Federal Flood Map Service. Type in your address. If you have ever heard the phrase 500-year floodplain and assumed it did not apply to you, this is the week to actually check, because a stalled system rewrites those odds. And while you are at it, find out the elevation of your access road, the one road you have to drive to get out, because the danger for inland families is not usually the house. It is waking up to discover the only road out is already under 2 feet of water, and you waited one tide cycle too long to leave. Therefore, the exposure map for this pattern is far bigger than the beach towns everyone pictures. It stretches inland along every river that feeds the coast. And that realization sent me back to the data with a sharper question. Because if the block was going to hold the water high for multiple tide cycles, then the exact timing of those tide cycles suddenly mattered more than anything else. Which is when I found the thing that no one in the coverage had connected, and I need to show it to you now. Here's what I did next. I pulled up the tide tables, not the forecast, not the storm models, just the plain astronomical tide predictions from the National Oceanic and Atmospheric Administration's Tides and Currents Service. These are the tides that happen with no storm at all, driven purely by the moon and the sun, and I lined a storm window up against them. That is when the last piece clicked into place. And honestly, it is the piece that made me sit back from my desk. The middle of this 10-day window lines up almost perfectly with a perigean spring tide. Let me explain what that is in plain language, because this is the term the coverage keeps skipping. A spring tide happens around the new moon and the full moon, when the sun and the moon pull the ocean in the same direction, and the high tides run higher than normal. A perigean tide happens when the moon is at perigee, the point in its orbit where it is closest to the Earth, so its gravitational pull is at its strongest. When those two things happen at the same time, you get a perigean spring tide, and people on the coast have a nickname for it. They call it a king tide. It is the highest naturally occurring tide of the month, sometimes of the season, and it floods low-lying streets even on a calm, sunny day. Now, put the two together. You have a storm that a blocking ridge is holding against the coast, pushing water onshore for multiple tide cycles. And the natural tide underneath all of that is already running at its absolute yearly high because of the perigean spring alignment. The storm surge does not build on top of a normal tide. It builds on top of a tide that is already near the top of the gauge. That is why the exact dates matter. Look at where the storm window and the king tide overlap, and that is your danger zone. The specific high tides where the water has the best possible running start. And this is the part that made me want to make this video tonight instead of tomorrow. When I went back through the reporting, the tide alignment was almost nowhere. The forecasts talked about the storm and its potential rain and wind. The astronomical tide is published separately on a different agency's website, and almost nobody was overlaying the two. But the tide gauges themselves do it for you if you know where to look. NOAA runs long-term tide stations up and down this coast. Places like the Battery in New York, Sandy Hook in New Jersey, Sewell's Point down in Norfolk, Virginia, and Lewis in Delaware. Every one of those stations publishes both the predicted astronomical tide and, during an event, the observed water level. The gap between those two lines is the storm surge. And when the predicted line is already at a king tide peak, even a moderate surge on top pushes the observed line into major flood territory. So here is the reveal, the thing I want you to walk away with, because it is simple and it is real and you can act on it right now. Do not wait for a wind number on the news. Go to NOAA Tides and Currents. Find the tide station closest to you and look at the predicted high tide times for the 14th through the 17th. Write those exact times down. Those are the hours when this coastline is most exposed, when the natural tide, the blocking pattern, and that overheated shelf water off Cape Hatteras all point in the same direction at the same moment. The storm can add its surge to any tide, but if it adds it to one of those king tide peaks, that is when the record books are in danger. That overlap is the signal. It was sitting in two separate public data sets the whole time, and almost nobody laid them on top of each other. Let me make sure you understand why this is such an advantage for you and your family. Storm forecasts shift. The track wobbles. The intensity changes. The models disagree right up until the last day. But the astronomical tide does not wobble. The moon is not going to change its orbit. Those king tide times for the 14th through the 17th are locked in, and you can know them today, days before the storm details settle. That means you can plan around the most dangerous hours before anyone else is even talking about them. You can move your vehicles to high ground the evening before a king tide high water instead of at 3 in the morning when the water is already at your tires. You can decide which high tide you need to be out of a flood zone for instead of guessing. Most people in these events lose their margin because they are reacting to the storm. You can get ahead of it by planning around the tide. And also tide is the one thing that is already certain. And think back to what the warm water off Hatteras really tells us in this whole picture. That 78-degree reading is not just about whether a storm forms. It is about how much punch the storm carries when it gets here. Warmer shelf water holds the system's strength closer to shore, delays the weakening you would normally count on, and adds a small extra rise to the water level all on its own because warm water physically expands and sits higher. Every ingredient I have shown you feeds the same outcome. The warm water is the fuel, the blocking ridge is the parking brake, and the perigene spring tide is the floor that everything is stacking on top of, a floor that is already raised higher than any other tide this month. That is the case, laid out one reading at a time, exactly the way it assembled on my screen over the last couple of nights. A buoy running 6 degrees hot, an index sliding negative and building a wall to the north. A history of stalled storms that killed with water, not wind. A compound flood threat that reaches far inland along the rivers. And a king tide sitting right in the middle of the storm window that the coverage treated as a separate footnote instead of the headline it should have been. None of these numbers were secret. They were all sitting in public feeds from the National Data Buoy Center, the Climate Prediction Center, and NOAA Tides and Currents. The story was in the space between them, in the overlap that nobody bothered to draw. Here's what I need you to feel walking away from this. The people who come through these blocked coastal storms with their homes and their families intact are almost never the ones who reacted fastest. They are the ones who saw the shape of it early, who understood that the quiet number, the water level, was the one that mattered, and who used the days they had. You now see what was hiding in plain sight this week. You see that the danger in this pattern is not one dramatic gust. It is the ocean being held high for days on top of the highest natural tide of the month. That is a different kind of threat. And it rewards a different kind of preparation, and now you know which one. If you are the kind of person who would rather read the real reading behind the headline than swallow a softened summary that leaves out the part that floods your street, then you already know why this channel exists. I do this because I got burned once trusting the tidy version. and I promised myself I would read the data myself from then on and bring you what I find. So here is what I want from you right now. And I am asking directly because this audience is too smart to stay silent. Go pull the predicted high tide times for the 14th through the 17th at your nearest NOAA station and tell me in the comments what you find. And tell me what region you are watching from. I want to see this coastline map itself out in the comments, station by station, town by town, so we can all see where the king tide peaks line up with the storm window. If you are inland, tell me which river basin you drain into, because I read every one of these and I will flag the compound flood risk spots I see. And if you want to be one of the people who sees the data before it becomes a headline instead of after, subscribe and stay close this week, because I am already watching the next thread. And it is a strange one. There is a second buoy further up the shelf that just started reporting a wave period that does not match the wind speed near it, and long period swell arriving before a storm is one of the oldest warning signs there, is that something bigger is organizing out over the open water. I am pulling that reading apart next, and I want you here when I do. You're still here, which tells me you want the real detail. Inside the Weather Watch, I take this forecast further, hour by hour, right where you live. And you can ask me your own question. A real person, me, answers you myself. You belong here, with thousands of weather watchers already inside. Just point your phone's camera at the code on your screen, and you can cancel anytime with one click.